Okay, welcome everybody. I'm David Blevins. Been involved in JavaEE for a long time. It's a subject pretty close to my heart. So who uses JavaEE? Let's see. Okay, the majority of the room. Who has historically avoided it? Come on, there's got to be some hands. All right, good. I mean, not good, but that's what we're here to talk about. So I've been involved in the EE specifications since EE6. Prior to that, my first spec that I ever worked on was EJB 3.0. And we did a lot of fun stuff in that. And we've changed the platform in a lot of ways which I think have been not understood. So this is what this talk is about. So the first thing is, we couldn't possibly cover all of the things that have changed in JavaEE for the last several years. This talk is not about the specifications and necessarily, I'm not going to read you all the changes. This is not a change log of the last 10 years. This is the big stuff that you may have missed, may not have come out. The big picture ideas that may not be seeable or visible in all the presentations about the various APIs that you see on a regular basis. So this one's trying to just give kind of a more overall perspective of JavaEE in general and where it's going. So I have sort of a Charles Dickens approach, trying to go back to front a little bit. We're going to spend very little time on the past. We will cover it a little bit. But I just want to get some of the big hits out of the way. This is still too many topics. I always prepare far more material than I can actually present. So, we'll see what we can get through. And by the end, hopefully we can at least, wrap it up very nicely. So, first thing, what has happened since the days of J2EE? All right, so there are what I would call maybe like 4 big changes that has happened since the CMP2 days or the EJB 2.0 days. The big one is annotations. And so who is aware that annotations actually were added to the language in response to basically heavy amounts of XML being produced in the EJB spec, pretty much? If you don't like EJB, but you like annotations, there's a little bit of an internal conflict that you've got to work out there because one made the other happen. So effectively, XDoclet was this piece of software that would allow you to use JavaDoc annotations above your methods and would process them into XML. And then, all right, people are like, cool, I don't have to write XML. This is really great. So then at the sort of Java level, back in Sun headquarters, they said, what can we do to make all this stuff easier? No idea is taboo. And someone sort of said, well, there's this kind of cool thing out there that makes all of what we're doing consumable. Maybe we could just add it into the language. There's little annotations in JavaDoc. And so that's where annotations come from. That's why they're styled after JavaDoc annotations. So this is actually a very big game changer that happened, and not a lot of people know the history behind it. And so I always kind of giggle when I encounter somebody and they say, oh, I hate EJB. And it's like, cool. You're like, annotations are pretty cool, right? Yeah, great. All right, well, you're welcome. You don't have to use EJB, but, sometimes bad decisions make very good things in the end. You got to learn your lessons sometimes the hard way. And that's one example of them. Another small change we made, or rather kind of nice big change, was we eliminated ear files from JavaEE. They're still there, of course, but we made it possible that you could put everything that you want, EJBs, everything, CDI beans, JPA, all that stuff goes into the web app now. So if you have an ear file and it's got a bunch of libraries in there and there's exactly one web app in that ear file, you can get rid of that ear file at this point. There's no reason to have what I call the Russian doll packaging. It's kind of ridiculous. I mean, you take a jar and you put it in the web inf lib directory of a web app. Then you put the web app in another archive with other archives in it, and you wrap it all up as an ear. It's like, how many packages within a package do we need? It's kind of ridiculous. So we collapsed all that down. So the WAR file is king now. The web profile was created. So who's aware of the web profile? So, and that's what surprises me. So the answer to that was probably about 40 to 30% of the room. So the web profile is roughly half of the full profile. So what we did is we took JavaEE and we took a real serious look at it and said, do people need all the things that we're still including in JavaEE? Probably not. Who uses Corba here in this room? Okay, well, okay, one person, or maybe two if I missed your hand. And that's in full profile JavaEE. We're carrying it forward for backwards compatibility reasons, so this one or two people don't have to deal with the breakage, but that's still important. And who uses JAX RPC? This is the old stuff before JAX WS. Okay, we had a couple. I seriously respect the hands that went up. That's a horrible spec to have to deal with, and so you really earned your stripes, and battle scars are sexy, so it's cool. Yeah, so we have a lot of things that are in the JavaEE platform which don't need to be in kind of modern runtime. So we created the web profile to acknowledge that. It's roughly half the full profile. As well, that was done in EE6. In EE7, we actually took another step by reducing the full profile just a bit. So things like JAX RPC are not required, but it still includes the standard hits, JMS, the connector architecture, JAX WS. These things are not in the web profile. The web profile cuts out JMS, JAX WS, and larger things like that. So we now have two flavors of JavaEE. One is significantly smaller, and a lot of people do not know that this has happened. So I always sort of make the joke where if you're talking with somebody and they're complaining about how big and bloated JavaEE is, and you ask them if they know that the web profile exists, and they say, what? Then kind of maybe, take what they're saying with a grain of salt. Might be a little outdated. Okay, so cool stuff that we've added since then are the presence of embedded containers. So let's take a just quick look at what that means. So here's a simple project. It's got two class files in it, so ignore all the outer stuff. We've got a simple calculator bean. It's a stateless bean, has add, remove, add, subtract, basic math, and we have a test case, and that test case has a before that boots an embedded EJB container right in the test class. And then we have, after that, real simple JUnit style methods. Real simple stuff. Now if we run this, it takes longer for IntelliJ to get things going than it does to actually run the test. That was about 2 seconds. That was an EJB container running in Java SE. All the transaction managers there and all the fancy stuff is there. And this is very different than what we've been marketed EJB as, which is heavy and big and bloated. Let's ask it just an informal question. How many people think that this doesn't match what you've heard about EJB in the last several years? Yeah, that's a lot. That's a lot of hands. This is not what we're told EJB is. It's like a boogeyman that people use to try and make everything sound really complicated. Does that sound complicated? It's pretty simple. You can do all sorts of things with this embedded container that you couldn't do before. One of them is sort of a microservice pattern. So here's a little project. We got a little main class, public static void main. I'm a big believer in giving people flexibility in how they consume JavaEE. I don't believe it should always have to be this sort of, here's a server, here's an app, put one in the other type of scenario. You should be able to have everything in one class path in one VM. And it doesn't have to be this crazy class loader hierarchy thing. And it can actually operate like a plain Java SE application. And this is kind of one of the things we're doing in JavaEE more and more, is making it consumable in very simple scenarios. So here I'm just going to boot my JavaEE container, or rather my EJB container, and I've got this one simple class called microservice, and it's got one RESTful service in it, and all it does, just for simplicity's sake, we're not doing any fancy marshalling. We're just going to return some basic JSON ourselves. And so we can go to the command line here. I'll show you the command, Maven clean install, skip the test for the moment. And what this is going to do is actually going to make an Uber jar. So there's a Maven plugin that will actually take all your dependencies and throw them together into one executable jar, and then we can execute that from the command line. Let's increase the font here. Microservices jar. Now it's booting up a JavaEE application with an embedded container, and we can go to this URL here. Let's maximize that. There we go. And invoke our RESTful service. There we go. We got some JSON back. So this is also probably one thing you didn't realize was possible with JavaEE. Most people will think, oh, I need to do microservices, so that throws JavaEE out the window. No, it doesn't. We're actually making very conscious moves to change that the deployment model that I mentioned, standard server application one and the other, that's fine for a lot of scenarios, but it shouldn't be all the scenarios. I think it's wrong when we kind of hold the APIs hostage to one deployment model, and just because the deployment model doesn't match doesn't mean you have to throw the baby out with the bathwater. You should be able to still use those APIs and get that functionality even if you want to boot the whole thing up in a different way. It's totally fine. One of the things that I think we should do more of in EE8 here was we have this embedded EJB container API, but we really need this to be kind of an embedded JavaEE API. So actually what I showed you is slightly outside the spec. It's possible to do now. This is supported. This is OpenEJB that I showed you. The REST part of it kind of falls outside the window of what is in the specification. And so that brings up the second topic, which is if you want things like that, who would want to be able to boot a whole container that fast in a plain Java SEVM and do microservices with JAX-RS and all the stuff that we offer as EE libraries? Who would want that? Yeah, that's a lot of hands. So it's currently not a spec requirement, but it could be. And here's how you make it a spec requirement. We have this thing called the Java community process, and before this was incredibly closed. But some milestone changes to the JCP have happened over the last 10 years, and a lot of it has gone unnoticed. So I'm going to tell you the story of openness in the JCP. So prior to 2004, we had open source JavaEE app servers such as JBoss and Jonas, but they weren't able to actually get the JavaEE TCK to get certified and couldn't actually be an official licensee of JavaEE. They had never passed the compliance tests. So when you used those, you were sort of gambling on your portability. We also had Geronimo, was one of the founders of Geronimo, that started in 2003, moved into Apache. And when we did that, we worked with Sun at the time, Apache did, to get the open source projects TCK so we could actually have certified servers that were open source. So in 2004 is the first time we saw open source certified servers in JavaEE. At that exact same time, we also invited these open source communities into the JCP to participate. And that was a very big milestone change in JavaEE, or specifically the JCP, over the prior 10 years, over the prior few years, I should say. A lot of people checked out of JavaEE in the 2006 timeframe, and they didn't get to see the change that subsequently happened after that because of that slight opening of the JCP. The next milestone change was in 2009, and that came in the form of two specifications being added to the JavaEE platform, which were not controlled by one party. In fact, these were added at inject, which was started basically by Google and Bob Lee, and CDI, which is Red Hat, and Bean Validation, also Red Hat. All these three are Apache licensed TCKs and Apache licensed reference implementations. So this is a very significant thing because it means that instead of JavaEE as a set of technologies being effectively proprietary and the TCKs to pass the certification for all of them being completely closed, we now have some open source getting a foothold inside the actual compliance portion of JavaEE. This is a small little win that is actually very significant. Then another change was in 2011, big thing happened. We made a new JSR called Towards Openness in the Java Community Process, and that was 348. And that basically said, we're liking the way that this openness is affecting the JCP and the community process. We're going to make it mandatory that all specifications have to be open. This was a huge, huge change. And the first round of specifications that took advantage of this was the JavaEE 7 set of specifications. So actually JavaEE 7 is the first JavaEE platform developed without smoke-filled rooms. That's a very significant thing. We're making great progress in the JCP. We've got a little ways to go still. I'd say we're halfway there. When we can get more openness in the TCK itself, so that way if you have a problem with compliance, you can deal with that by actually requesting tests to be added to the TCK because you can see it. Or in some way, we need to allow you as consumers to be able to have a stake in your own compliance. If you're facing a compliance problem, you should be able to contribute a test, or at least ask for the test to be improved. This is something I think we need to do over the next 10 years of JavaEE. We'll get there, but it's something that you should start asking for as consumers of JavaEE. It's within your right to have a stake in compliance. You're making the biggest investment in this. All the investment that we make as vendors is small compared to the investment that you collectively make. So use your voice and ask for more openness. Typical standards FUD. I just want to run through this real quick. We're clearly preaching to the choir because all of you use JavaEE. But I have a problem when I hear people talk about the specifications in a way that is not in alignment with what standards are supposed to do. So one of them is, why is JavaEE getting left behind and that kind of thing? That's like, okay, let's get something clear. Standards are not supposed to be out in front leading and guessing. The problem and the penalty for guessing wrong is very, very large. It's huge. You have to live with that for 10 years. Can you say CMP 2.0? I mean, you know, that's what happens when you guess. What we want as an industry is for vendors to go out and little projects to go out and experiment with things, get them right, we weed out the bad ideas, and then they come back into the standards, and then we could all rest calmly on that for 10, 15 years. And yes, more things will come out, but we don't have to worry about the incompatibility problems. Other portions of our industry haven't figured this out. We're jumping onto the coolest, latest ship, and guess what? They throw us a curveball once in a while. And many of you have heard that Angular 2.0 is going to be nothing like Angular 1.0, and there will be no backwards compatibility and no migration port layer. So, okay, you know, good for you guys. We're very fortunate that we have an industry of standards in Java. Ruby doesn't have it. JavaScript doesn't have it. We're the only ones. You know, it's a unique thing. Take advantage of it. So the other one is portability. Here's why I have the biggest problem. Have you ever heard anybody say, well, I tried to port my app and it didn't work? So portability sucks. It's a pipe dream. It's not real. To that I say this. Portability is not a silver bullet. It's a life raft. When the ship is sinking, you either have some hope of moving your people onto another ship or no hope at all. There's no portability when people are going from Angular 1 to 2 or going from, you know, .NET to something else. Any portability is good. Well, you have to adjust your expectations. Portability is a chance to survive. Just because you encounter some problems with it does not mean that the whole concept is flawed. If you want to move your database from one database to another, it's at least in the realm of possibility, but moving your data from a SQL database to a non-SQL database is very difficult. We have those two choices to choose from. We either complain that it's not completely perfect and that we abandon it completely, or we acknowledge the fact that at least we have some portability there, and we can increase that in portability by participating in the JCP, by asking tests to be added. That will improve our portability, but let's adjust our expectations for that. Who's heard of CDI? Who uses CDI? Okay, that's a good portion of the room. So I always go over, so I will skip the CDI portion of it, but I will simply say that CDI is the new core of JavaEE. If you haven't really taken a look at it, do so. It's where everything is standardizing. Who finds it frustrating that all these specifications we have in some way duplicate each other on very simple levels? Well, that should be all the hands, because I find it incredibly frustrating. I find it unsatisfying and not acceptable. We need to change this and fix this. So CDI is more and more the integration point for JavaEE. It's a great spec. Go take a look at it. Who's heard of our Killian? Okay, we have about 40% of the room on that one. So here's some cliff notes, because you can go out and see tutorials on our Killian pretty much anywhere. Here's some information you really won't see just listed on their website. Our Killian is a testing framework that allows you to write tests in a way that are not specific to the server, but actually they're plain JUnit tests. And the great thing about that is it's similar to previous ideas like cargo that would allow you to sort of boot server, deploy the server, run the test, and then undeploy the app, shut the server down, that kind of thing. What's different about our Killian is a handful of things. So one, yes, it's 5 years old this DevOps. So happy birthday, our Killian. Round of applause for our Killian. The other one is it's got 100+ contributors over the last 5 years, which is very good. The last 3 are the most significant. Cargo eventually ran out of steam because it's very hard to write adapters and keep them going for all these servers that change version after version. The adapters break, and if people aren't there to maintain them, they eventually stop working, and the whole system sort of decays over time. So our Killian was written because Red Hat, who had the responsibility of writing a TCK for CDI and bean validation, and when I say TCK, I mean the set of tests that anyone must pass to claim that they implement CDI or bean validation. They had to write this test case, this test suite, and they wrote it in the open source. And they eventually came up with a pretty good framework for doing that. And since all the vendors had to run and pass that test suite, they had to work out all the kinks of making it possible to do that. So what we ended up with is our Killian. And it's used by 2 TCKs, and all the vendors, IBM, Oracle, Red Hat, Apache, we all have to pass these tests. So it means all of our servers have to basically implement our Killian adapters. So this is a perfect scenario for you guys. If you want to write tests and write applications that are portable amongst many servers, you can write those tests in a way that are not specific to that one server. So it's very much within your best interest. If you have the desire for portability, that is a great way to do it. Even if you don't have any plans to port from one server to another, my testing philosophy is such that I think there should be 70% tests for 30% code. So the greater portability concern is not the runtime, it's the tests. So wise up, start testing, and take a look at our Killian. All right, so these are some things that have gotten some warts about JavaEE in the past. These things are now fairly easy to do. I want to save more time so I can focus on the fun, cool stuff that we can do in Java 8, JavaEE 8 and beyond. So here's a cool one. So who's heard of Spring Data? Okay, that was like 60% of the room. So I've got a really cool alternative for Spring Data that I want to show you. Okay. So here's the Spring Data example straight from their website. So we got a user entity. It's got queries on the top, real basic getters and setters. And it's, of course, like I say, straight from the website. And we have a repository, which basically represents the simple create, update, remove, delete type of logic. All repositories extend CRUD repository, and you say what the primary key type is and what the entity type is. And you have basic interface methods, so you can do this type of find by this, find by that, and list, and you can put the queries right there. So if you run this, this is the Spring one. We run it, should be pretty quick. Okay. All right. So that ran in about 5 seconds. It's pretty cool, pretty light. Allows you to remove the boilerplate. So here is the cooler alternative. Check this out. You're going to love it. It's incredibly original. So we have our user. The data's gone, but here's the important part. We have this simple user repository that extends CRUD repository. It's got the primary key type and the entity type, and then find methods in it. And we have various types of things that we can return. And we have a simple test case for it. And we'll go ahead and run that. Okay, and that ran in about 5 seconds. So, who totally knows that my version is way better? Come on. Got to have like, no, okay. Who can't really tell the difference? That was the entire room. Okay, I got a little secret for you. The second one I showed you is CMP2. No joke. That's a CMP2 entity container. The thing that we always say is the worst part about EJB, and that the Spring community has said is the horrible thing for years. I compared them both. They ran at the same time. You couldn't tell the difference. I'm cheating, however, because in OpenEJB, we rewrote our CMP container on top of JPA when JPA came out. So we're really comparing apples and apples here. And that's why they're the same. They look the same. But the API style is taken straight out. So if you actually go and look at the simple data version, user repository extends CRUD repository, which actually just extends EJB local home. So it's a home interface. So yeah, it's the point here is that sometimes the things that we tried early on in JavaEE or in Java in general didn't work, not because that they were bad ideas. It's the tools that we needed to implement them were not there at the time. So Spring Data, it does way more than what I showed and what CMP2 ever did. It's better. But the fact of the matter, they're based in the same exact idea. And it's easier to implement now because what I didn't show you on my example over here is the gobs of XML that you would have had to have dealt with in order to do what I showed you. This is horrific. No one wants to write that, and yeah, it's terrible. So that's why CMP ultimately failed, because you couldn't take the metadata and attach it onto the actual objects where it should have been. And so every time you changed or refactored your code, it was always breaking. It was horrific. So the things that we did in the XML time frame of JavaEE may have been pretty good ideas, but we didn't try some of them again in the annotation era of JavaEE because we learned our lesson. Well, there's a lesson to be learned that's bigger than that, which is sometimes you need to retry the ideas when the technology advances. Very big lesson to learn. The things that you may have tried before maybe didn't fail because they were bad ideas. A friend of mine says all the time, a good idea at the wrong time is tantamount to a bad idea. That's CMP too, definitely. Also, never confuse ideas with execution. A lot of the lightness we're seeing in JavaEE isn't because the specifications have changed. It's because the way we implement JavaEE is changing. And so that lightweight EJB container can actually do, is doing the CMP. It's doing all the old stuff. But it's not heavy because it's old. It's heavy, it's light because even though the ideas are 15 years old, if you try them in a new way, you will get a new result. Okay, so one of the things that we want to do in JavaEE 8 is security. And a big portion of that is authorization. So here is how some basic security looks currently. And I'm getting Twitter's, I don't know how to shut that off. Okay. Thank you for the tweets. All right. So you have this roles allowed, and that allows you to say who is able to access and invoke these methods. And by the way, let's acknowledge the elephant in the room. Who uses JavaEE security? Wow, that's more hands than I expected. That was like 5% of the room, which is like 5% more than I thought. So that's really cool. It should be 90% of the room or 50% of the room at least. So I'll tell you what's currently on the slate for being improved in EE8. So currently improved is this, and I'll go ahead and run this little test case just for fun. We've got a little test case that allows you to execute these methods, and I do a trick. This is a testing trick you can do now in EE6 or beyond. It looks fancy because IntelliJ makes it look like lambdas, but basically the trick is if you want to test security, you make a bean, annotate it with run as, you give it a callable, and then you pass your logic in, have it executed in the context of a manager, and then you can test that the security checks are implemented and working correctly. So we have one bean to run things as manager and one bean to run things as employee, and now we just do some basic create, update, remove, deletes on our bean here. And the cool thing about this, and this is a fun thing we can think about for the Java 8 portion, if we wanted to, we could probably make this a lambda if sometimes IntelliJ uses that functionality and sometimes it doesn't. All right, showed us as a lambda, but I'll go ahead and run it just for fun. Oh, it's green, but you missed the. Okay, so here is an alternative way that we can do this with one of the potential additions for Java 8, which is this concept of meta annotations, which I'll talk about subsequently. And instead of having to put @roles allowed and @ so on and so forth on the actual beans, we can actually put something like add permission and have that annotated. This syntax would be wildly different for Java EE8. But basically, we're moving and wrapping up the annotations in a way that allows us to take the roles and move them somewhere else. That is a potential portion of discussion. This actually works currently, so I can run this one as well. So here's the alternate version of the security API. What is definitely on the table for Java EE8 is making it possible for you to do that type of role-based authorization, not just in an EJB, which is kind of where it lives now, but also to be able to do it on CDI, do it on a JAX-RS endpoint. It's perfect. JAX-RS is brilliant place for roles allowed to be placed, because if you have various get methods and put methods and delete methods, it's very, very realistic that you will want to say who can invoke them without having to write the boilerplate code all the time. And so being able to have that type of functionality in the JAX-RS setting is incredibly attractive. And so we're definitely going to be making that possible. If we can improve it further beyond that so we don't have to copy and paste the role names all over the application, that would also be very attractive. Okay, so that leads me to the second part of the security thought. So that definitely addresses authorization, but it doesn't necessarily address what I consider everything else. And so here's a way to look at security in JavaEE. All right, we have a lot of APIs which focus on the inside of the server. We have the JAX spec, Jazz spec, we have JASPC, we have the role-based authorization. All these things focus on the inside of the server, and this may have been acceptable in the time, in the era where the client was expected to be some Java client, and the server vendor would just control the authentication, and whatever protocol they wanted to use was fine. JavaEE comes from Corba types of backgrounds in the very, very early days, EJB types of things. We have an app client container. Who even knows what an app client container is? Yeah, okay, that was like 11 hands. Yeah, that's this one whole specification about how would you write a client in Java and have a little mini EE container to do various functionality for you. It's unused. So today, our clients are increasingly not Java. JavaScript owns the client these days. And so if you have all these APIs inside the server that help you implement various role-based authorization, but the authentication portion of it is wild, wild west and not under any specification really, that means your portability is inherently affected. And this is a bad thing because the client is going to be a significant amount of your investment. And so if you're writing this client and the authentication between you and the server is, something beyond basic author message digest, then you're in undefined territory. Out of curiosity, the other aspect of it, well, first of all, out of curiosity, who's still using basic auth only? Only? Like, okay, who doesn't use any security at all? Okay, thanks for your honesty. That was like 3 hands that were the brave ones that were willing to admit. I assume there were more hands that didn't go up because your bosses are sitting next to you. Okay, so OAuth 1. Okay, so we're going to OAuth 2.0. All right, so what security framework are the people who didn't raise their hand? You said no to basic auth, no to no security, no to OAuth, and no to OAuth 2. Someone shout out something that you're doing for security protocol if there is one. Oh. What's that? I didn't understand you. Oh, SOAP? Fabulous, you said? Kerberos. Oh, thank you. Okay, well, let's do that one. Kerberos. Okay, well, we've asked a lot of questions, and very few hands have gone up about what people actually use. And so for the life of me, I can't tell what the room is using because I said no security and went through all the ones that no hands went up. This is really confusing to me because when we did a survey about the top functionality that people wanted in Java EE8, security was like the top. And I definitely agree it needs to be addressed, but I'm also curious what we would do in that space, not because there aren't options, but I want to make sure that what we do in EE8 is actually going to match what people are doing now and is useful and is going to turn Java EE security into not that thing that I guess that sort of works, but I don't know anybody who uses it, to you're not using it, what? It should be the latter. And I think that's going to require us to focus on the client-server communication portion of it and acknowledging that, hey, you can't just abstract users out into nowhere. So who stores users in database? Yeah, that's what I thought. So that was like a good 30% of the room. Who stores users in some form of LDAP? Okay, yeah, and you know, that covers the majority of us. If we just like blessed those and said all vendors must have a database form to store users and LDAP support, that would get us so much further in the security story than, I think, improving the inside role-based authorization that nobody uses. Okay, so a really, really cool thing that's happening in JavaEE 8 is a revamp of how we consume JMS messages. And this, you have to see it to believe it. Who saw my EJB 3.1 talk, or 3.2 talk from last year? Okay, just like 3 your hands. So this won't be incredibly boring for you. Okay, so today, JMS to you, at least in terms of consuming JMS messages via, like, you know, in a servlet style of just invoke me when a message comes in, is done with an MDB, and I'm going to close all these other things. Okay. So what we have in MDBs is basically, and I can shrink that just a bit, is we have what we call, this is a message-driven bean, and it's horrific and mortifying and terrible in so many ways, it's hard to count them, but I'll try to list 3 of them concisely. Okay, so 1, name-value pairs as a form of configuration inside an annotation. What is going on there? I mean, annotations are supposed to provide you a way to attach metadata onto a class or an object in a strongly typed way, but we've said, hey, cool, now I can put my name value pairs in there. I always sort of joke that the first business that made it really work on the internet was Amazon, and they sold books. It was sort of like, hey, we can share information, cool, I can buy books on these things. You know, it's like, okay, well, it was, you'll get it in a few years, you know. And so when we made annotations and attached them to JavaEE, we didn't revamp message-driven beans at all. We took the XML and we moved it into annotations, but since the name-value pairs are sort of up to the vendor in a lot of regards, we just punted on it and said, all right, well, we'll go ahead and make it so you can have a loosely typed name and a loosely typed value. And this is horrific. That's it should be strongly typed. That's problem number 1 with this. Problem number 2 is, well, documentation. Like, everybody take a real good look at the screen, and then now tell me what name value pairs are acceptable on an MDB. Okay, yeah, you could maybe list 1 if you were paying really close attention. So every time we have to do one of these, we go find some other piece of code that had it, we copy it and paste, or we go surfing through some documentation. That's a serious waste of time. That's problem number 2, that the options are not visible to us. Problem number 3 is this thing right here. That guy, that's terrible. That's not the way we design APIs anymore. This is rare remnant of the old servlet service method, or the do-get, in which case you get this big method with a what I call a very coarse-grained object that's a HTTP message, and another coarse-grained object which is an HTTP response. And you're required to do all the boilerplate of, grab these headers, see if these query parameters exist, make this one an int, make this one a Boolean, and you're doing all this parsing logic and all this basic setup, and then you do your little tiny code. And then you have to shovel all the stuff into the response, and you've got this much code, and that, this much boilerplate code and like that much real code in your servlets. That's what they look like, period. And when JaxRS came out, it said, hey, you know what? If you just tell me what header parameters you want, I'll give them to you. I'll parse them out into the data types that you want. And really, once JaxRS came out, it showed us the better way to design APIs. If you design annotations that describe how HTTP messages could be consumed, you can now allow users to have n number of methods with n number of parameters, and they describe them using the annotations you give them, and then you as the container can just figure it out. No reason for you to have to take your query parameter and turn it into a Boolean and always be dealing with the the checked exception that you get from that. Ridiculous. So this is what we still have with MDBs. We have still this one coarse-grained messages, the one-size-fits-all method. And because we have like 4, 5, or 6 different message types in JMS, we first, of course, have to very strongly make sure that which type is it? Is it object message? Is it, text or whatever? Okay, it's object. Great. Now we'll cast it to object message. All right, now we'll get the object from it. And then now we finally do something useful. All of this is stupid boilerplate code we shouldn't have to deal with anymore. That's the third, or at least I lost track, maybe the fourth really horrible thing. Here's what we're going to do in JMS next. Now, these annotations are not the official annotations because, specifications, they require input from everybody. But this is a for instance. Here is where we're going. Instead of name value pairs at the top, finally we can have some stinking annotations. I mean, these, if you want to, you can't misspell them, because this code will not compile. That's the definition of strongly typed versus loosely typed. And you can't get the data type wrong, because that also won't compile. And of course, if this is a standard API, you can go browsing around the other values, and you can see you would be able to see what other options there are. We've already done some major improvements about how we would work. And of course, vendors would be allowed to still have their own annotations on the top. So if you wanted to take advantage of some features of your JMS implementation, they could have a library with annotations that you use and put them in addition right up here. So, magic thing foo, and that would like do some crazy thing that only that JMS implementation supports. Also, you would be able to simply do this and have multiple methods. So this is a very JaxRS styled type of thing. So expect this to come out in the next version of JMS. It's going to really, really change the way that we do any kind of message consumption. It's what we've been waiting for. I think a lot of people were hoping that this would happen in JMS 2.0, and it didn't. We put the mechanism in there to make this possible. If you want to know what that was, it's basically a revamp of the connector architecture. I presented that last year a bit. You can go look it up on Parlays. But it's a pretty neat thing. So meta annotations is another fun one, and this one I'll do fairly quickly. So I've attempted to explain this one to a few times. And here we go. And let me hit the slide, that way Parlays can do their nice bookmarking. Okay, all right, so here we have a bean that uses the schedule annotation of JavaEE 6 or so, and you can say from May to June, execute the plant corn method. From September to October, execute the harvest corn method, and of course this is a farmer bean, and if you know anything about, and you know any jokes about farmers, they have to check on their daughters continuously, so this schedule executes every minute of every hour of every day. And so, har, har, har. But the problem with this is right here. We are copying annotations all over our code ad nauseum, and we think this is okay. Well, we think it's okay because we have no other choice, so we just kind of live with it. But wouldn't this, and I'll go ahead and run this so you can actually see it run. It'll take exactly 5 seconds because there's a timer in there, there's a sleep statement. And we just simply check that the daughters are okay at least 4 times in the times that we checked. And so here's the meta-annotation version of it. Meta-annotation is a simple concept of annotation reuse, putting annotations on other annotations to imply them. Here's the way that code should look. Who finds this significantly more readable? Yeah, of course. And if you wanted to have more than one thing be planted at specific times, you could reuse this and have the actual definition of planting time be defined elsewhere. Now, this is a pre-spec, pre-standard kind of prototype, so the implementation of it is ugly. But basically, you have an annotation called planting time, and on that annotation, you define the schedules that you would want that annotation to imply. This is basic annotation reuse. We have no ability to reuse annotations at all. They must be copied and pasted, full data and all, everywhere that we use them. And this is a serious problem. I have completely failed in a lot of ways to describe this in the sense that I don't think it's, yes, it looks cool, but it should seem like, wow, I can't believe we don't have this. There are 9 million Java programmers in the world, and each day we wake up and we copy and paste annotations all over our code, and we don't think twice about it. So here's another way to think about it. This is HTML. Who thinks that this HTML is the modern and good way to do it? Yeah, no one's going to be brave enough to raise their hand on that one. All right, here's what we do in Java code. Anyone see the problem? I mean, why do we think this is fine? In HTML, we abstract out all the things that decorate our tags or our methods and fields by putting them in a CSS. We make something that says a class that's titled, title or news, and we put all the things on it, and then we don't have to smear our formatting all over the place. This is what we should be doing in Java. This is so much better. Why do we not scream? We should be walking up to the Java SE team, shaking them and go, please, come on. But it took the HTML world 10 years to get to this point. So be patient, but also be demanding. So figure that duality out. Positively patient, I like to say. So here's my simple statement. You can tweet this one and record it. Java without meta annotations is like HTML without CSS. We need them. We need them bad, especially with the number of specifications that are coming out that are adding more and more annotations all the time, and they're stacking up. And some code looks like more annotation than it looks like real code. And I think it's maybe hard for it to be seen as critical when there's just sample code that has 1 or 2 annotations on it. It doesn't seem important. But when you have a huge code base, wow, is that a maintenance problem? It's terrible. So that's something we could do in 8. We discussed it in JavaEE 7. We really wanted to do it. At this point, I think it probably should be done at the Java SE level. It really should just be part of the VM. So we will continue to pursue that one, but please start asking for it. So the final the fun thing, lambdas and Java 8, and how will that affect JavaEE? That's a fun topic. So here is some simple code. a lot of the things that we do now programmatically, or excuse me, declaratively, are very hard to do programmatically. So I'm going to show you this example. Remember our farmer. We've got these annotations and how simple this code looks. Even without meta annotations, it's still fairly simple. To do this exact same thing, this is declarative. These decisions are made at development time and deploy time, and they can't be changed later. They're annotations on methods, and so this is declarative programming. And if we want to do this and make this logic happen at code in runtime, we have to do things a little bit differently. So here is how we would have to do that. This was released. This is the schedule expression. This is the programmatic equivalent to the annotation that we saw. You can do this in JavaEE 6 and onward. So we have to create a schedule expression. So we'll just show you one of these data types so you know what you're looking at. So you create this schedule expression object, and then you go ahead and you make a calendar timer with that schedule expression, and you pass in a timer config. And then all of these calendar timers that we created 5 of them, and these are equivalent. They all go to this one method called @timeout, and you get, again, a very big coarse-grained object. And in the coarse-grained object, there is inevitably some logic to figure out what you really need to do, and then you have to, of course, go and execute that method. And so by the time we've actually gone to our real code, we have a significant amount of boilerplate that we have to get through. This is unfortunate, but it's very difficult to do at runtime what annotations can do better at declaratively. And so we are sort of stuck. We have some limitations with us in this regard. Here's a way that this could be done with lambdas or method references. So this is a theoretical API. We still create our schedule expression, but instead of passing in like a state object like we did before, and then having to look at that state object, instead, why don't we pass it a method reference right there? And now we're actually describing behavior, things that we want to have at some other time or whatever, and then we're passing a method reference into it and saying, when this time comes, invoke this method. This is way cleaner. It may not look so prolific in this regard. I mean, this is already far simpler of a runtime API for doing it than the previous one. Can you imagine having to do 100 schedules with annotations? That would be very, very cumbersome. In a runtime, in a programmatic way, it's far simpler. So this is just simply one example of what we could do with lambdas and Java 8 functionality. The other one is that security example that we showed. Here, I'll show it over here. This is just begging for a lambda right there. This whole thing could just be one big lambda. And then you would just simply have this. And now you could pass, basically a lambda in, and actually, instead of having the logic about whether or not you want this method to be invoked in a transaction, or you want this method to be asynchronous, and you have to put this on annotations on the method itself, you could push that to the caller and allow the caller to make those decisions, because the caller could simply pass that method in to something which would wrap it effectively and make it asynchronous, or make it execute in a transaction, or make it execute as a particular user. So this fundamentally changes the way that we do things. So there are 3 predictions I have that Java 8 will have on JavaEE. The first one is that our annotation declarative approach is no longer going to be the king. We will be able to do a lot more things programmatically. Interceptors will be less important because you can pass a method reference into a method reference into a method reference, and that effectively, at runtime, makes an interceptor stack. So you can do decoration and wrapping of methods in a way that was impossible before. The other one is it pushes the control or allows control to be shifted from the person writing the method, doing the coding of the specific thing. Right now they have to make the decision, should this be in a transaction or not? Should this be executed by the security requirements or not? Should this have these various interceptors? All of these decisions have to be baked in and made in advance, and a lot of them can be pushed to the client now. These fun things are going to fundamentally change the way that we're doing things. Logic is now mobile and movable, whereas before it was fixed and static. So we had to have annotations to move the world to these methods because methods were immobile. So we put all annotations on that stuff. It forces us into a declarative paradigm, but now that methods are mobile, it changes everything. So I would summarize this talk with this. There are basically 3 eras of JavaEE. The first era was the XML era, whereas that was the primary tool we had aside from Java itself to get work done. And a lot of the APIs that we created, such as CMP2, didn't work out so very well. The annotation era started in 2006, and that's where we're in now. And the Lambda era, the Java 8 era, is upon us. So we have this opportunity to redefine JavaEE again, and I think we should all get involved in the specifications at this point. Because it's our standards, it's our language, it's our platform, and now we have an open JCP, whereas before we didn't. We have the opportunity to change JavaEE significantly. All the APIs are going to be redone with these new concepts. Get involved in the specification. I like to say it like this. Openness and standards must be earned. You can't just sit there and wait for them to be delivered to you. If you want openness, you've got to participate in them. If you want standards to be more value to you, you need to participate in them. Be a game changer. The biggest game changer in Java is you. Thank you very much.